better. 3.2, day 1. Today we're talking about complex numbers. We're going to start by simplifying the square root of 72. How does one simplify square root?
Done by the square roots that are perfect.
Divided by the biggest perfect square to start. What's the biggest perfect square 72 divides by? 36 times what?
2.
Aiden, can you not see from there? Okay, so square root of 72 is 36 times 2, both inside of square root. Which of those two actually simplifies?
36.
Square root of 36 is?
6.
So it becomes 6 squared is 2. Square root of 25. That one is a perfect square, so it just becomes 5. Square root of a negative 16.
Not possible. No real solution.
No real solution implies I asked you to solve. Did I?
I don't know.
No solution implies I asked you to solve.
4.
It is not negative 4. But those of you who are telling me that it's no solution, that we can't do this, you're on the right lines, assuming, of course, you're sticking with the real numbers.
Imaginary numbers.
Today we're getting into imaginaries.
Yay.
So I haven't been waiting for this all happening.
Imaginary numbers.
In your hand, shit. It sucks.
Imaginary numbers work with what's known as the imaginary unit. The imaginary unit is given by the letter I, that lowercase I. Oftentimes, it's italicized, and the reason they italicized it is so it doesn't start looking like a 1, but that's neither here nor there. I is by definition the square root of a negative 1. Which means if I want to do the square root of a negative 16, I am going to break it up into the square root of negative 1 times the square root of 16. The square root of negative 1 becomes an I, and the square root of 16 becomes 4. But the typical way that they write it is with the whole number followed by the imaginary piece. Continuing to simplify a little bit. Negative square root of negative 49. What does a negative outside of a square root do?
Flips the value. Reciprocates.
It makes it negative. I know, mind-blowing, but my point in pointing that out is that sometimes people look at the negative in front and automatically they go, imaginary. No, a negative out front does not make it imaginary. A negative inside makes it imaginary. Is this one imaginary?
Yes.
Yes. Now I can break it up into separate square roots if I want. I pull the negative 1 off, and when I divide negative 49 by negative 1, I'm left with a positive 49, and then I can simplify each individual piece. As a result, I would get negative 7i.
That's interesting.
Do I?
So he was talking about how he knew the answer already.
No, actually, I heard what
No,
he
no, no,
said.
no. He said that after.
That was afterwards.
He was talking about math.
Anyway, what about a square root of a negative 20? Find the perfect square that 20 divides by. What's the biggest perfect square 20 divides by? 4. Now the negative is going to be a square root of negative 1, and then I get a square root of 4 and a square root of 5. Make sure you're doing this as multiplication. A couple people on the quiz treated it as subtraction or as addition. They were adding the two numbers. They're being multiplied. Square root of negative 1 gives you what? I. Square root of 4 gives you 2. Square root of 5 gives you
Square root of 5.
the proper order.
2 square roots of 5i.
Square root of 5.
2i square root of 5.
Wouldn't that be F?
I labeled it a little differently as I did this last year, and so I just copied down the C from what I did in my plans. My bad. No, I did not change the alphabet to go to A, B, C, D, E, C. What's the negative 4 doing? What? Yeah. It's multiplying by the square root is what I was trying to go after. Negative 108. What am I going to break it up into? It's the first thing I break off. It's the first thing I've been breaking off. That negative 1. What perfect square does 108 divide by? Does divide by 9, but there's a bigger one.
36.
36. 36 times 3. If my brain immediately went to 9, would I still have been able to do this?
Yes.
Yes, it would just take more steps. I would have had a square root of 9, and then it would have been 9 times 12, which would have been 3 square roots of 12, and the square root of 12 I would then have to break down as well. Do I get there? Yes. Is it longer? Absolutely. Negative 4. Square root of negative 1. I. Square root of 36. 6. Square root of 3.
Square root of 3.
Square root of 3. What order am I going in? Negative 24. I square roots of 3. Has simplifying square roots with negatives inside changed them that much?
No.
No. The only difference is that when you have a negative inside, you're going to get an I out of it. Now, if you are a person who can look at negative square root of negative 49 and go directly to negative 7i, that's okay. I break down every step because of the fact that I don't want people losing pieces in between. But I'm okay if you skip some steps, as long as it's reasonable on what you're skipping. Now, These are straight up imaginary numbers. Imaginary numbers are numbers in which the entire number has an imaginary piece. There is an I connected to this entire -7. There's an I connected to the entirety of the 2 and the square root of 5. There's an I connected to the entirety of the -24 and the square root of 3. But our section is not called imaginary numbers, it's called complex numbers. Complex numbers are numbers with both a real part and an imaginary part. If there is no real part, it's pure imaginary. It fits in the complex numbers, but technically it's pure imaginary. If there's no imaginary part, it's just a real number. A complex number generally is written in the form of A plus BI, where A is just a placeholder for the real numbers. It's the real part. And the BI is the imaginary part. With our imaginary numbers, we are going to do some simplification. I've got two complex numbers right here getting added. If you add real numbers, are parentheses necessary? When you add binomials that have real numbers, are parentheses necessary?
Yes.
Like this. Are the parentheses necessary? No. Guess what? When you add complex numbers, the parentheses are not necessary. Now imagine these weren't complex numbers. Imagine this was some binomials where I was a variable. What would you tell me to do at this point?
Combine like terms.
Guess what? Do that. 3 plus 5? 4i plus a -6i?
-2.
Ta-da. You added complex numbers. When subtracting, do you think that there is an importance to the parentheses? The second set of parentheses has some importance to it. Because when you deal with binomials and there's a minus, what do you have to do? Distribute that negative that's hanging out there. Guess what? Do that with complex too. 7 plus 2i minus 8 minus 4i. Any thoughts on what we do next?
Combine like terms.
7 minus 8? 2i minus 4i? Still feeling okay? What do you mean it's the exact same thing?
So the exact same thing is if you distribute the 3 and the negative, and then you add them all together.
Do y'all agree with Luke?
Yes.
Do you think that's what we're gonna do?
Yeah. I didn't even hear.
Yeah. I am adding a real number, a pure imaginary number, subtracting a complex number, adding a real number times a complex number. Doesn't matter. It's like combining like terms and multiplying and distributing. Distribute your negative. Distribute your 3. Being careful. If this was -3, I'd be distributing -3. And then combine like terms. I've got a 12. I've got a -12. I got a +12.
12.
12. I got a 7, a -1, and a -3.
3.
3. But not just 3, 3.
I.
Now, is there a little more complexity to simplifying with imaginary numbers? Yes. Are we talking about that complexity today? Not yet. We'll get to that tomorrow. Now, there is another set of instructions you're going to see today, though. Well, we are going to solve for the variables, assuming that as we do that, that those variables are real numbers today. Okay. These problems are going to look a little weird, though, compared to things we've seen in the past. Because in the past, if we saw an equation like this, we would say it's impossible to solve. Because it looks like I have a single equation with 3 variables in it. But I don't. First off, how many variables are here?
2.
2. X and Y are variables. I is not. I is the imaginary unit. Can we typically solve a single equation with 2 variables? No. The number of variables you have needs to match the number of equations you have if you're working with real numbers. These are not real numbers, these are complex numbers. Here's the nice thing about complex numbers, specifically about the imaginary part of it. I is the square root of what again?
-1.
-1. Now let's imagine that I take that I and I multiply it by a real number, because we set up here, we are assuming that the variables are real. So let's say I do 2i. That is 2 times the square root of -1. With me? Do you recognize that that is still an imaginary number? Okay, let's take an ugly real number, like the square root of 7, and multiply that by I. That is the square root of 7 getting multiplied by the square root of negative 1, which is the square root of negative 7. Do you recognize that that is still imaginary? Do you think that multiplying an imaginary number by a real number is ever going to be anything other than imaginary?
No.
If you multiply imaginary by real, it will always be imaginary. Why is that helpful? These are complex numbers. This is real. This is imaginary. This is real. This is imaginary. It doesn't matter what numbers I am multiplying by. When I multiply the real by the imaginary, it's going to result in imaginary. Furthermore, if I take real numbers and multiply them together, they end up being real. So it doesn't matter what I multiply by any of these, they're going to stay real. Here's the short end of it. You see something like this? The real part is always going to stay real. Therefore, you can set the real part equal to the real part, and you could set the imaginary part equal to the imaginary part. That's real and that's real. 4 equals 12y. That's imaginary. And that's imaginary. 5xi equals 18i. Start here. How do I solve for y? Divide by what? 4 divided by 12, also known as 1/3. Y is 1/3. If 5xi is equal to 18i, I could divide the i's off both sides, and I just get that 5x is equal to 18. How do I solve for x? Divide by 5. Let's try one more. Complex number equal to complex number. Anytime you see that, we can set which part's equal. -3 would be equal to what? Three-fifths x. How do I solve for x when it's got a 3/5 in front of it?
Reciprocal.
To divide by a fraction is to multiply by its reciprocal. -3 times 5/3. -5. Let's solve for x. How do I get y? -2yi. Do I need the i's?
No.
No, negative 6 equals negative 2y. Y is 3. Those of you who've been dreading complex numbers and imaginary numbers, are they that scary?
No.
Yes.
Caleb.
You're scared of imaginary.